The old path sum 2 problem, which is the most important depth first search problem you're likely to encounter. Everybody has to do the path sum 2 problem. It's absolutely the greatest, bestest problem you've ever heard of. Nobody could live without doing the path sum 2 problem. Just one question. What is the path sum 2 problem? Okay, so it says given the root of a binary tree at an integer target sum, return all root to leaf paths where each path sum equals target sum. A leaf is a node with no children. They give an example here. The target sum is 22, which could be formed by 5 plus 4 plus 11 plus 2, or 5 plus 8 plus 4 plus 5. So that's what we need to return. And here they give the example of target sum equals 5. And we see that 1 plus 2 doesn't equal 5, nor does 1 plus 3, so you return nothing. Likewise, you're given a tree which has nodes of 1 and 2, and the target sum is 0, so no combination of 1 plus 2 or 2 plus 1 can equal 0. Okay, so how do we want to play this? Well, it is a depth first search, and what we're going to do is go down the binary tree until we hit a leaf, which is a node without any subnodes, or child nodes as it were, and we're going to check the sum up until that point, and if it equals our target sum, we're cool. Then we just push back onto our main return vector the current vector that we had accumulated so far as we were going down the tree. So let's do that. Okay, so first a little sanity check. If the root is null, then return nothing. Consider that this language is legal in C++. You don't need to create a return vector. That just wastes memory if you don't need it. Otherwise, we're going to create, our return vector, which is a vector of integer vectors. We're going to call it myReturn, and then we're going to eventually return myReturn after we fill it. But in order to fill it, we're going to have to populate it. In other words, yes, we're going to have to populate myReturn. So first we're sending the root, then we're sending myReturn, then we're sending a blank current vector. That's each of these, and at the moment it's blank. What else do we need? We need the target sum. We need the current sum is 0. And I think that's it for now. Let's see if we could do something with that. So let's create our in-order traversal. So this is the function we were talking about, which takes a tree node root. So since we're not modifying the root, we don't need to put an ampersand here, and that's fine. Then we're throwing in the myReturn, which we're going to pass by, here we do, by reference. Later, we're also going to pass in a vector of integers by value called current vector. And we also want to pass in the target sum. And likewise, we could pass in the current sum. Okay. Now I'm going to see if we ever need to. If we need to change those from something that's not const. We'll see that in 2 seconds. So the first thing is our root condition here. Well, first, if whatever we're looking at is null, then we could return. So there's nothing to do in this case. Now, if we got somewhere, now we're going to do current sum plus equals, what is this? Current sum plus equals root val. And what else do we want? We also want to insert the current sum in our current vector. So current vector dot push back, and we want the root dot val in there. Okay, so now we're going to do our little checks here. So, okay, if root dot right equals null and root dot left equals null, that means we hit a what is it? A leaf node. So if that's the case, then if what is it? If target sum, sorry, if current sum equals target sum, then that means we could add to our myReturn vector, and we're going to push back the current vector, and then we're just going to return. So that's what we do if we found a leaf node. Otherwise, oh yeah, the values could be negative, so we're not going to return if we go overboard, so that's fine. We're just going to continue iterating down the tree. Okay, so if we hit a... So, okay, if root dot right not equal... what is it? Not equal... what is it? Not equal null, then what do we want to do? We want to send in order, and we're going to just throw in root.right. How do we write this? And then we're going to throw in myReturn, and we're going to throw in current vector, which is getting stuff pushed back as we iterate, and target sum, which doesn't change, and what is it? Current sum. Okay, now obviously current sum, we could pass it by value over here because it's going to be modified, and we definitely don't want it by reference in there. Now we're going to do the same thing here. Okay, so if root.left not equal null, then we're going to throw this in as well. And I think that's it. Actually, so this is not really in order. Actually, we had to... So actually, I think this is probably something like pre-order, so don't take my word for it. Or what is it? Post-order, or something like that. Yeah, or post-order traversal. And the reason is we're doing our current node first, and then we're doing the others. But actually, it doesn't even really make a difference as long as you go somewhere. Let's just run this, see what happens. And it looks like it worked. Now let's submit. Okay, it worked. Now the only thing you need to remember is that it probably wasn't in order over here. And that looks like it works. Thanks a lot, folks. Have a good day.